Welcome to the last session of the day. This is 13.3B. It sounds like you're sitting in airline seats. You know, it's not exactly what. So if you've been wondering what these little robots with blue eyes are around, we're going to find that out in this session today. So they have been all over the place, and they were not the ones that spilled water in the main hallway either. So that was an excellent one here. We have with us Justin Swansberg, who is, if I read this correctly, a data scientist for Trusted AI.
Correct.
Never heard of that particular one before, but setting focus on strategy here, and what we really need to understand is how to trust AI, because it is a interesting technology and it can be abused and misused and underused and overused in very, very many ways. Justin, I'll turn it over to you. Thanks for coming.
Thank you so much. Thanks everyone for having me. I get to spend the next 30 minutes with you all talking about trusted AI and really the systems that monitor them, run them, and govern them. Before we get into that though, I want to take a second and talk a bit about who DataRobot is, where we started, and a bit about where we plan to go. We actually recently celebrated our 10-year anniversary. We were headquartered here in Boston, Massachusetts, and our offices are down in the financial district. Once I get this slide to progress here. There we go. So a bit about DataRobot. We, like I mentioned, are 10 years old. We've raised over $1 billion in venture funding. We have right around 750 data engineers and data scientists that are actively working on building out our end-to-end data science platform. We were the original creators of what's now called automated machine learning, or AutoML. And from there, we went on to found the category of automated time series, and then MLOps as well. And we're going to talk about how all of these things intertwine, especially around trust. The last thing I want to mention is with our platform, we like to provide a space for multiple people across the business to collaborate. We feel like in data science today, there are often far too many silos and too many people building AI systems separate from either the business or the folks that have to go and operationalize those. And if you don't have good alignment across the business, then you don't have good lines of defense against these fairness and bias issues. In terms of who we work with, we like to say that our platform is industry agnostic. That means we are horizontal. We work across many verticals. You can see here on the screen, we work with 8 of the top 10 US banks, 7 of the top 10 pharma companies, half of the global manufacturers, as well as retail, telco, insurance isn't listed here, but they're also a big client of ours, and healthcare as well. So rather than focusing on any individual industry, we tend to help industries enable and solve a large backlog of use cases by leveraging AI. So we focus on what we call solution accelerators, helping people go faster from data to value, leveraging that asset they have across the business and acting as a force multiplier, either for data scientists or what we call capable and motivated business analysts. And the question we always get asked is, if you're broadening this community of AI creators, aren't you worried that they aren't trained like classical statisticians or data scientists? Where does the governance come in? And that's a big part of trusting the systems you build. In fact, that's what I want to spend the next 20 or so minutes talking about. And before that, I want to tee up why bias is so important. In fact, I think it's quite topical since it comes up a lot in the news as well. You see it across many headlines, AI has been a buzzword of late. Two headlines that I do want to talk about quickly. One at the bottom of the screen there, if you've heard, is the issue that Apple and Goldman are facing with their new credit card offering. There were some tweets that went viral when a few new clients, females, realized that the credit limit that Apple automatically assigns through the result of their algorithm was lower than the credit limit they assign to males, even when they were married and shared the same bank account. And if you don't dig in beforehand, and if the teams responsible for building, maintaining, and operationalizing these systems don't check for these biases beforehand, then you end up as a headline. Second thing I want to talk about here is loan originations, which is also quite important and germane today, where there's regulatory restrictions. So there's two classes of companies that should care here. There's the general, because you want to protect your brand and your reputation in the market. And then there are the whole class of organizations and enterprises that are subject to regulatory scrutiny, whether you're in finance, insurance, et cetera. Especially when you are offering or originating loans, there are strict policies you need to follow in terms of protected categories, whether that's veteran status, gender, race, ethnicity, et cetera. So where does bias come from? There are really two core sources. The first is people, and the second is the data you use to train your algorithm. People have inherent prejudices that they're going to inject into the machine learning process. One thing people fail to appreciate is that a person framing the problem they're going to use AI to solve is just as important as the AI solution itself. When they make decisions around how to structure the question, which data to use, how to implement it, when they're going to implement it, and why they're implementing it, they're subjecting the entire process to potential biases. The second source, data, is where we see inequity and unfairness pop up the most in practice. Models are greedy. They are going to mine whatever relationships or patterns they can find from your data set to build as accurate as possible predictions. If your data set has any biases built in, the models will learn those and perpetuate them forward. So you need to not only understand any of the biases in the training data set, but also monitor them consistently over time. Since once your model's trained and in production, if you start feeding it biased input data, the model, even though it was unbiased to begin with, may inherit some bias. The big question that I want to ask, and actually debunk, is can AI models be unbiased? And what do we mean by bias? It's a bit of a loaded term, since there's a technical answer in data science. In this case today, by bias, we simply mean, do the AI and ML models that you and your team build treat individuals differently? If I make a prediction and decide how likely a patient is to be discharged, can that probability or likelihood be different based on race, gender, age, sickliness, past history, et cetera? And so the answer to this question really is, of course they can, but the whole purpose of building a model is to find that bias and discriminate. That's why we build them. A model that is unbiased isn't going to treat people differently, which defeats the purpose of building the model in the first place. So a better question isn't, are my models unbiased? And we'll come back here in a second. But it's whether your models are fair. Is the bias that your models are picking up on actually fair? And I'm going to evaluate fairness, especially in the Data Robot platform, through these four categories. You've got people, you've got development, which is technology, process, which is our machine learning operations. That's what happens to these systems when they're live in the wild. And then underpinning all of these is the regulation, the ecosystem outside of your company. And before we jump ahead, I want to go back and give two examples to highlight the difference between bias and fairness. The first one here is looking at an insurance policy. Imagine we have a data set across the country. There are old drivers and younger drivers, and we're trying to predict claims. And we're going to use those predictions to set premiums, high or low premiums. Well, a model might look at past data and decide that based on that historical data set, older drivers tend to file fewer or smaller claims. Therefore, they may be assigned, based on the output of that model, lower premiums, where younger drivers might have the opposite impact. The younger you are, the larger your expected claims. Again, that's a pattern the model found in the data. That is bias that it's leveraging. It's exploiting that bias to make a more accurate prediction. Is that right or wrong? In this case, and insurance is a highly regulated industry, it is not one of the protected categories for this type of loss cost modeling. You are fairly allowed to build your models with age as a factor. Now, there are rules and regulations around it. In fact, in this particular example, you need to ensure that you have what's called monotonicity. As people get older, you have to be able to prove that your model's expected premiums fall, because we believe, and our laws dictate, that they are safer. Now, on the other hand, if we flip from insurance to loan approvals, back to that loan origination example I mentioned, you can imagine rather than old drivers and young drivers, we have men and women. And we're looking at the likelihood that they've defaulted on their mortgage applications. And it could be the case that based on our data set, the model determined men repay loans at a higher rate. And I have no idea if this is true. And women, on the other hand, tend to repay less often. The model would then exploit that difference and code gender as one of its features and use the difference in gender to help apply different predictions when that model is deployed into the wild. This is an example of a bias you want to avoid. It's unfair bias. You aren't, in fact, laws and ethics dictate that you cannot originate a loan or extend a mortgage to a loan, an applicant, rather, as a loan officer if you discriminate on sex. So jumping forward, how do we go about preventing these? First thing we learned is that fairness and bias are two different things. Models are built to uncover bias. As practitioners, we need to make sure that bias is fair. And we view fairness through multiple different lenses. In terms of setting up a system to prevent them, I'm going to spend today talking about a system that's known as the Swiss cheese model. And that is the technical term. It's actually been applied in the airline industry quite successfully. The reason it's called the Swiss cheese model is that if you look at the visual up on the screen, it looks like slices of Swiss cheese. Each of those slices is one line of defense to prevent against these types of inequities creeping into your AI systems. But no one slice alone can prevent all of them. So you can imagine lining up these 3 or 4 walls of defense, and combined, they capture the majority, if not all, of these possible inequities. And again, the 4 walls being people, process, technology, and then regulation. So let's unpack these. People. I mentioned at the beginning, there are a lot of contributors when you build out an AI system. You've got folks that maintain the database, folks that source the data. You've got business folks that create and formulate the problem. You've got folks that train the model, manage the pipelines, deploy the model, document the model, audit the model, operationalize the model, and folks that manage change management. They all come from different aspects of the business, and that's important because they are optimizing different cost functions. What they care about is different, role to role, and business unit to business unit. And if you aren't all aligned and working in a single unified platform, then you can lose sight of exactly which optimization function you're leveraging and which constraints you're subject to. To make this a bit more concrete, imagine we're building a model to predict optimal staffing at a warehouse because the warehouse operator wants to improve his margin or bottom line. There might be a separate HR team involved that cares in terms of their loss function at maximizing employee happiness. So they are competing. This is a multivariate cost function here. And if you aren't aware of all the goals, then you can't possibly be aware of all the biases and inequities you need to check for. So the best way to defend against people injecting bias into the process is through education. You need to make sure that you have the right support. You need to have a shared language, so you're talking about these problems in the same way, a shared vocabulary, and you need to increase the AI fluency or literacy across your organization. And the second key pillar is technology. By technology, I really mean the development of AI and ML, building models. What you think about when you picture a data scientist sitting behind his or her workbench, coding away. If you don't practice ML correctly, you can inject a lot of unfairness and bias as part of that process. And I'll go through, in a slide or two, strict examples of guardrails that you'll want to set up to prevent leaks like that. This slide is a bit of an eye chart, but only because there are so many different angles you need to be aware of. And one reason we're big proponents of a platform that you can have that system, that consistent process to check for all of these different leaks every time you address a new use case. And I won't touch on all of them, but I do want to touch on a few in different aspects. So this pie chart's built out of operations, performance, and ethics. And we're going to start down in performance. So if we're building technology to prevent unfairness or inequity from creeping into our models, we're going to want to start with making sure that the models extrapolate well. We're not overfitting the data, and there's no target leakage. It's a concept in data science where you leak information from the future into your model. In order to trust the insights that you're building, which we'll tackle in that next stage, the next slice of the pie, you need to have an accurate model. If it's inaccurate and you can't trust the insights, you've got no baseline or benchmark. So one is a strict process that separates your data correctly, ensures your models are accurate and generalizable. Two, up in ethics, are the insights. This is where human in the loop comes into play. You can build models, and you need systems that analyze all of your models, evaluate them, and explain them in the same way every time. Feature impact is an excellent example. This is going to stack rank all of the features or attributes your model cares about that explain how accurate it is and exactly how the model arrived at its predictions. Which features contribute most to the model's performance? And this is where validators and auditors, especially groups such as the model review or MRM management teams, they leverage insights like this to make sure that the model stands up. It aligns with scrutiny, common sense, and their team's ethics and in the use case's stated goals. The other one, and we're going to spend a lot of time talking about this, is bias mitigation. There's three components of fairness and bias, both detection and mitigation. The first is understanding how representative your initial data set is. Again, if there are biases baked into the data, your model will learn those. The second is checking if your model introduced any of these biases once it was built. And the third is actively monitoring for those biases, monitoring those protected categories over time to make sure they don't creep in after the model's been deployed. So in the Data Robot platform, and we will touch on this, we check for all of the above. We will flag data quality issues and distributions to start, which is a best practice. When we're building the model, we'll run insights for each protected category that you highlight to ensure that we're not treating any of those classes differently or unfairly. And then once that model gets deployed, which means it's in the wild scoring predictions, we'll track those same features to understand if the fairness or bias changed relative to what we measured at training time. The final slice here is operations. And I think this really wraps everything together. There's both all of the lineage and history you need to prepare and consolidate. In data robot speak, we call that automated compliance documentation. That is a single repository or reference for anyone looking to analyze or investigate the model that shows the entirety of the workflow. In statistics, there's a replicability crisis. A lot of the results and papers that were published, they cannot be replicated for a variety of reasons. One potential solution is having econometricians, statisticians, whoever's practicing, write out their exact experimentation in advance. That'll prevent them from making some choices that lead to spurious correlation or overfitting. The same is true for machine learning. When you're reviewing the entirety of the process, you need a single document that explains every decision you made, which is why for data robot, when we talk about documenting the model, it's not just X's and O's. We aren't just going to explain how accurate it is. And we're not going to go into detail, or just go into detail, on the exact type of neural network or XGBoost model we built. We also leave sections and placeholders in there for the business to explain why they frame the problem, why it matters, who it will affect, and how the model will be used in production. If you don't understand the entirety of that ecosystem from a holistic point of view, you can't prevent all these biases. And the final thing is the workflow approvals. That's understanding the right people. You've stood up the right checks and balances at the end of the process. Speaking of approvals, this matrix on the right-hand side of the screen has two dimensions. There's severity and there's frequency. And this is how I normally suggest teams stand up their approval processes. So each cell in the matrix is some combination of a high severity bias and some level of probability, which means in the upper left-hand quadrant, you've got the really high severity issues that have really high frequency. They happen often, and when they happen, they're really bad. In the opposite corner, you've got the inverse scenario. Events that don't happen often, when they do, they relatively small impact. So when you set up a criticality workflow, you want to make sure you've got different gates and checks and balances based on where the use case or where you expect the use case to land in this table. If it's in the upper left-hand corner of the matrix, that needs to be your highest risk level. You need to scrutinize that and demand more documentation and more of these lines of defense than the use cases in the bottom right. For Data Robot, we have an approval process set up that lets all of these practitioners and creators assign these two dimensions that will trigger separate workflows for different auditors or admins to come in and approve not only the particular model, but the entire end-to-end pipeline before it sees the real world. Some examples of these different severity and frequency levels. You can imagine the claims I spoke about earlier. If you're predicting highly severe claims, imagine asbestos. You're going to want that to be subject to a much more scrutinous process. Whereas if you're predicting something like how likely a car crash, an accident, is to get fully paid back, you might not need as much scrutiny. Same goes for the originations, the mortgage applications we talked about. In fact, one more example I'll highlight is resume screening. You can imagine that recruiters, especially when they're piled behind a long list of candidates or applicants, need to rely on straight-through processing or automation to help that first round of screening. If I have 10,000 applicants and I have 10 recruiters, I can't possibly manually review every one. But if I introduce automation, it might fall for some of those biases. One simple example is actually hiring in our space, data science and engineering. there are far less women. There are far less female applicants and far less female employees. A model is not going to understand that the ratio needs to be corrected. It will learn that men tended to be hired more often. So if you were to deploy that model without the appropriate checks and balances, it would recommend that your company hire more men. The last thing that I'll address after this slide is how we can actually mitigate those biases, since there's no way to avoid them. They're going to creep in. You've got to monitor for them and then correct them. There's no such thing as a pristine data set without bias. Before we get there, though, that fourth and final piece of or slice of Swiss cheese is the regulatory environment. And this is so important because it does, to a certain extent, dictate the walls or those guardrails that you do set up. Depending on where in the world you are and what industry you're in, you are subject to different regulations, and these are dynamic. They're evolving. In fact, the EU right now, which is generally regarded as the strictest and most progressive, is already spearheading a new AI policy that's going to govern how you build, deploy, and monitor these policies. There are other governments, like Singapore, leading the charge with their own prescriptive modeling from frameworks and strategies. And even our own Federal Reserve recently has been issuing MRAs. They're asking companies to come back and present to them what their strategy for monitoring models looks like. So to wrap it up here, I want to highlight how DataRobot as a platform can help tackle those final 2 points I mentioned. Let's assume that bias is going to creep in, or unfairness will creep in to our model. What do we do about it? Well, the first step, like I said, was to have a system that's constantly monitoring for it when you build new models. So at the very top of the screen, you can see the example of sex. We've got males and females. We can actually monitor the percentage, let's go back to the hiring example, percentage of males that the model actually suggests we pass on to the next round. And if we have a threshold that we also monitor, then we can get alerts when the model detects that ratio violates some threshold. And the second piece is bias mitigation. There are 2 strategies built into DataRobot to take a model that's learned an unfair bias and undo it. The first is called reweighting, where you actually alter the input data set to make it more representative of the population you want. And the second is post-processing recalibration, where in data science in general, especially if you're predicting a yes or a no, a true or a false, any probability prediction that's closer to 0.5 is less certain. The model isn't quite sure, and with more uncertainty, it tends to make predictions closer to that midpoint. So the second process actually looks at any of these predictions around that threshold or cutoff and will move them from the unfavorable class to the favorable class. Again, our hiring example, taking women right around the threshold that the model decided shouldn't get passed through and changing the decision. And the third and final is once that bias has been corrected, you deploy the model, actively setting up an MLOps strategy, machine learning operations strategy, that's going to constantly monitor those same protected categories you flagged to make sure the situation doesn't change, since we all know the real world changes every single day. With that, I'm going to skip through this example here as we spoke through it, and I'm going to end on a slide you've seen. It's those 4 slices of Swiss cheese. You need all 4 to make sure that you protect yourself and your company against all these possible sources of fairness and bias. And that is my 30 minutes. I will open it up to questions with a little help, but thank you, everyone. Appreciate the time.
And thank you very much. You have a question on the internet here. It's how do you rate if a model is biased or not? Is it a binary thing, or is it something beyond that? Is there a standard practice to this approach?
Yes, there actually are standard practices, I'd say. In fact, if you were to look at the DataRobot platform, there are different standards of what we would call bias. And there are different measures of calculating it. So in our platform, we actually have a workflow or a modal that allows users to answer questions and step through and prescribe which approach makes the most sense based on your business problem. A simple example is called proportional parity, and that goes back again to the HR hiring use case I mentioned, where you want to make sure the same percentage of men and women, rather than the absolute number, is equal. And there are 4 or 5 different commonly accepted methodologies. The trick is understanding which one to use, and that requires a little bit of science and know-how.
I guess something of this testifies to the fact that you've been around for 10 years, so congratulations for that. But also you seem to have learned a whole bunch from that as well. Do we have any questions in the room? All right, well, we have run out of time. Justin, thank you so much for a great presentation.
Of course.
And
Thank
for
you
you guys supporting the event.